Hello everyone! Welcome to lesson number 3 of Unit 1. We're talking about something called absolute value functions. Absolute value functions are pretty easy. Let's go over what an absolute value is. Absolute value is the distance a number is from 0. It's written with 2 long lines to represent the function absolute value. And I have a little disclaimer here, right? Distance is always positive, right? Even if you're walking backwards, right, doing the moonwalk, whatever, you're still going a positive distance, right? So it doesn't matter which direction you go, distance is always positive. Here we go. We have an example. If we were to say the absolute value of 3, the distance 3 is away from 0 is 3, right? 3 units away. That also works for negative 3, right? The distance away from 0, negative 3 would be 3 units away. So basically, and be cautious with this, but basically, if you have a negative value inside of the absolute values, when it comes out, it should become positive. Now, other things might happen to it after that, but anything that's inside of an absolute value that's negative will come out of that as a positive. Okay, so let's look at evaluating a couple of these functions. They're really not that bad. Right, they give us f of x equals 2 times the absolute value of x minus 4, and then they give us a whole bunch of different ones they want us to look at. Right, we'll start with negative 2. So I'm still evaluating negative 2 in wherever I see an x in this formula. Right, so negative 2 goes in here. I have to treat these as if they were parentheses, so I have to take care of anything inside of here first. Negative 2 minus 4, that's negative 6. Now, I'm at the point where I have to get this thing out of the absolute value brackets. So when I look, the absolute value of negative 6, how far away is negative 6 from 0? It's 6, right? Just pretty much you get rid of that negative sign at that point. And now we can do the multiplication. 2 times 6 gives us 12. So if I plug in negative 2, I expect to get 12 out as a result. And we're going to repeat this for each of these values, right? If I do f of 0, zero minus 4 gives us negative 4. The absolute value of negative 4 is positive 4. 2 times 4 gives us 8. So if we plug in 0, we should expect to get 8 out. And we keep doing this, right? F of 4. Four minus 4 gives us 0. The distance 0 is away from 0 is 0. 2 times 0 is 0. So if I plug in 4, I should get 0 out. Let's try 6. Six minus 4 is 2. Well, this is not a negative number, but it doesn't matter because the distance 2 is away from 0 is still 2 away. And then we can do 2 times 2, which gives us 4. So if we plug in 6, we should expect 4 out. And our final one, 10. F of 10. Uh, 10 minus 4, that gives us 6. Absolute value of 6 is still 6. 2 times 6 is 12. So if we plug in 10, we should expect 12 out. Okay, so I went through that one problem. We evaluated a whole bunch of different values. I went through that kind of quickly, but I'm hoping at this point that you understand that just because we're evaluating a different type of function doesn't mean that PEMDAS changes, right? You still do the same order of operations. You still do your arithmetic the same way. You just have a new type of operation. How it works, you take a negative that's inside, it becomes positive on its way out. Okay, so I've got one for you to try right here. See how you do with it. Pause the video and resume when you're ready to check. All right, let's see. I'm going to switch my marker here because that one looks like it's kind of dying. We want to try -5 first. So f of -5. -5 minus 1, that's -6. Absolute value of -6 is +6. 6 over 2 is 3. So if we plug in -5, we should get 3 out. If we do -1, -1 minus -1 is -2. Absolute value of -2 is +2. +2 over 2 is 1. So if we plug in -1, we should get +1 out. If I evaluate 1, 1 minus 1 is 0. Absolute value of 0 is 0. 0 over 2 is 0. So if we plug in 1, we get out 0. And finally, f of 9. Uh, 9 minus 1, that's 8. Absolute value of 8 is still 8. 8 divided by 2 is 4. So if we plug in 9, we should get 4 out. So evaluating, not bad. You treat the absolute value brackets as parentheses in the order of operations. When it comes out, you just get rid of any negative, and then you continue to do whatever you need to from there. Now, evaluating, pretty easy. I think solving is a little more interesting because there's some things you got to consider when you're doing this. Okay. Let's look at our first example. We have 4 times the absolute value of 2x plus 3 equals 19. We're going to solve this like usual. There's only one thing that we'll have to worry about, and we'll get to that when we get to it. Okay? But for right now, let's just try solving this problem. We're going to solve it like usual. We got to get rid of some of the stuff that's surrounding the x. So let's start by getting rid of that plus 3. Right? That would be the first thing that I would want to do, is get rid of that plus 3. So we'll subtract 3 from both sides. We still have 4, absolute value 2x plus 3. Now we have this equaling 16. Right? And then we continue. How do we get rid of the 4? We would divide. So we still have the absolute value of 2x plus 3. 16 divided by 4 is 4. Now we've come to a point where we're down to just that absolute value, right? How do we deal with that, right? What do we do? Well, we actually have a couple of different options, right? Because we know that whatever's in here could be a negative number, but when it comes out, it's going to become a positive, right? So we actually have 2 different scenarios here. We have the option of 2x plus 3 being positive 4, right? Because whatever number this is, it's going to come out as 4. Or we could also have 2x plus 3 being -4 inside, and then when it comes out, it becomes positive 4, right? So those are our 2 possible scenarios here. So we have to solve each of these to figure out what number would give us a -4 or a +4 in here to make it become a 4, right? So when you're solving algebraic absolute equations, once you get down to this piece right here, if I got a positive number, I have to split this up into 2 different situations. And now I'll solve, right? We'll subtract 3 from both sides. 2x equals 1 divided by 2, we get 1/2. Over here, subtract 3, 2x equals -7 divided by 2. So we got, for this particular problem, positive 1/2 and -7/2. If I were to plug these numbers in, I would get 19 out. It doesn't matter that I get two different values inside of here, because once we take the absolute value, it becomes positive, right? So we get two different solutions. Try out this problem on your own. See how you do with it. Pause the video and resume when you're ready to check. Alright, let's see how you did here. We'll leave this one up as a reference. We want to start solving, so we got to get rid of some of the stuff. I hope that you got rid of this 5 first by adding to both sides. -25 plus 5 is -20. Then we'll divide by -2. 3x minus 2, still inside the absolute values, equals 10. So now we have two situations. We have 3x minus 2 could be 10 inside of here, or this 3x minus 2 could be -10, and then it would come out as positive 10, right? So we have those two different situations. Well, let's solve each of them. Add 2 to both sides, gives us 12 on one side, divide by 3. We get x equals 4. Over here, if I were to add 2, 3x equals -8. That can't reduce. So our solutions here is we could have either -8/3 or 4 will both satisfy our original equation. Hopefully you didn't worry about that fraction, because fractions show up a lot. Let's take a look at this problem right here. Same idea, right? We're still solving algebraically. So first thing that's got to go, we'll subtract 4 from both sides. That leaves us with 2 times the absolute value of x plus 2 equals -2. We'll divide by 2 on both sides. -2 divided by 2 is -1. And we're at a spot where you might be like, well, break it up, Mr. Marchetti. That's not going to happen here, though. And here's why. Anything that's inside of the absolute value could be positive or it could be negative, which is why we had two different situations on the last couple of problems. The problem here, though, is that whatever comes out, can it ever become a negative number just purely by coming out? No, it's always going to become positive. If we had something out here to make it negative, then maybe, but we would have dealt with that in our algebra a minute ago. So we don't have anything that could make a number become negative like this. So I don't have any solutions that I could plug in here to give us a -1 out. There are no solutions. So you might need to write that note down. If you get to this point where the absolute value equals a number, if it's positive, you break it up into two situations, giving you the positive and negative solutions. If you get a negative at this step here, you can't go any further. You can't get negatives out. Somebody set this up where it doesn't work. Okay? All right. This is the last little bit for this lesson. Absolute inequalities. Now we have some rules that you might want to take a second to pause and write down. We're going to refer back to them. They tell us that if the absolute value of x is greater than a and a is positive, then we have these two situations right here. We have x could be less than -a or x could be greater than +a. Or if we have the absolute value of x happens to be less than a with a positive, then we have a situation where x has to be between these two values. This is only for inequalities, and if you start doing these problems out and testing numbers inside of it, you start to see why these are working the way they do. Okay, so let's take an example right here. We're still going to solve like we were before, so I need to make sure that I start adding 5 to both sides to begin with. I'm going to continue, right? We'll divide by 3. So this gives us the absolute value of 2x minus 1 is greater than 3. Now, following these rules here, because the absolute value is greater than our positive number, I have these two situations. I have 2x minus 1 is less than negative 3, or 2x minus 1 is greater than positive 3. Why these two situations work, we're not trying to be equal to 3, remember. We're trying to get numbers that would be greater than 3. So if I have the situation here where whatever number that we had inside happens to be a negative number smaller than negative 3, I should be getting out a number larger than negative 3 as a result. That's because of the whole negatives inside become positive. That probably didn't make much sense, but that is how it works. Anyways, enough of me yakking. Let's solve these so that we can move on with our lives, right? We'll add 1 to both sides, and then we'll divide by 2, and we get x is less than negative 1. On this side, we're going to add 1 to both sides. 2x is greater than 4. We'll divide by 2. X is greater than 2. So our solutions here, x is less than negative 1, or x is greater than 2. So it doesn't matter if you pick any numbers that are less than negative 1, it'll work here. If you choose any numbers that are greater than 2, it'll work. We don't want to choose negative 1 or 2 themselves because they're not included. Let's try one more example of this. We'll start off by subtracting 1 from both sides. Then we'll divide by negative 2. And that gives us 3. So now we have the other situation, right? We have our absolute value is less than our positive number, a. That tells us that we have this situation going on. So our a value here is 3. So I'm going to do negative 3. Our function, x plus 3. And then I'm going to do our a value as a positive. And now I can actually solve this simultaneously, right? If I subtract 3 here, I can do it from here and from here as well. That gives me negative 6, and that will give me 0. So as long as I choose numbers between negative 6 and 0, not including those numbers, I will get something that will satisfy this equation. So you have 2 more left to do. I'm going to leave these up here as a reference. So once you start solving these and you get to a certain point, look back to these. Pause the video and resume when you're ready to check your solutions. Alright, let's check them out. I'm going to move those away. Hopefully you have those written down somewhere. I can still see them from my point of view. We'll start by adding 2 to both sides. Then we'll divide by 5 to clear out that multiplication. And it looks like that we want to use the 2 situations here, right? The OR situation. So we would say 3x plus 1 is less than negative 4, or 3x plus 1 is greater than positive 4. So if you got here, you're in really good shape. We just need to finish it off with a little algebra. Yeah, you're going to get fractions. Who cares? I don't. Solve the other one here. And here are your answers. X is less than negative 5 over 3, or x is greater than 1. You choose from either sides of those, it'll work in this equation or inequality. You had one other one to try. Hopefully you subtracted 3 to start. Then we'll divide by 2. Then we have our absolute value happens to be less than our negative number, so we're going to use the other rule here. So we're going to take our a value, which is 9. I'm going to make it negative 9. And I'm going to take it and keep it as a positive, right? So I have negative and positive version with our absolute value in between. And we can work on this simultaneously. So I can add 4 to both sides. That would give us, what, negative 5. And over here, 13. And then we'll divide by 6. So we would get negative 5 over 6 and 13 over 6. As long as we choose numbers in between, that equation will be satisfied. I think, let's take a peek. Yeah, we got a little bit more left to do. It's kind of a longer lesson, I guess, but this is it. So if you want to take a quick pause to stretch or something, that's up to you. This is the last little stretch. You're going to need some graph paper anyways. So let's take a look at what absolute value functions look like graphically. They're known as the V function because they make a V. It's that simple. All right, let's take a look at if we were to use a table of values here. I were to plug in negative 3 into the absolute value function, it's going to give me positive 3 out. Likewise, with negative 2, it should give me positive 2 out. Negative 1 should give me positive 1 out. And then from there, right, 0 would give me 0 because there's no distance away from it. The rest of these are the distances away, so they're just going to repeat. As far as graphing, right, these are in coordinate form. This is my x-coordinate. This would be my y-coordinate. So if I start negative 3, positive 3, and then negative 2, positive 2, negative 1, positive 1, 0, 0, that's what we get for anything that would be negatives, right? Any negatives that we plug in, it's going to give us positives out. This is why it's called a V function, though, because on the other side, we get 1, 1, 2, 2, 3, 3, and so on and so forth. And connecting all these points, what do you notice you start seeing? A V. Okay, I rest my case. So, we know what the general look of this function is. If we know how to manipulate a function based off of its vertex, you can do that from here. That's not what I'm going to suggest that you do. However, I think the best situation for you would be to evaluate and write down the coordinates. I've given you coordinates that I think you should check. Once you start seeing things change direction, right? See how I saw this was going this way and it changed direction? I know that it's going to look the same on the other side, so I can kind of shorten my work a little bit. But until we go over how to move or translate functions, I think you would be best suited to evaluate. So let's try this one together. Move this up a little bit. Okay, if we plug in negative 3, negative 3 minus 1 is negative 4. The absolute value of negative 4 is positive 4. 2 times 4 is 8. Minus 3, we get 5. So negative 3, 5. We repeat. If I do negative 2 minus 1, that's negative 3. The absolute value of negative 3 is positive 3. 2 times 3 is 6. Minus 3 is 3. So negative 2, 3. Now what's cool, useful, we see a slope, right? 2. Although right now it's heading in a negative direction, you can still see that you have a rise of 2 and a run of 1, which still matches with the 2. It's just heading in the wrong direction, but at least we have that height the right way. Let's plug in negative 1. Negative 1 minus 1 is negative 2. Absolute value would become positive 2. 2 times 2 is 4. Minus 3 is 1. And look at that. It continues to follow that spacing that we were hoping for. If I plug in 0, 0 minus 1 would be negative 1. Absolute value is positive 1. 2 times 1 is 2. Minus 3. We get negative 1 as a result. That's okay, because the negative 1 came after we subtracted that 3. So that's cool. Let's try plugging in positive 1. 1 minus 1 is 0. 2 times 0 is 0. 0 minus 3 is negative 3. So at 1, we ended up with negative 3. Well, this thing just keeps on going down. Do you think it will ever go back up? I don't know. Let's see. Let's plug in 2. 2 minus 1 is positive 1. Absolute value stays positive 1. 2 times 1 is 2. Minus 3 is negative 1. Hey, look at that. It looks like it's starting to come back up at this point. So I can predict, because it's going to be symmetrical, that my next point, 3, should be up here at 1. And I don't have to do all that evaluation. I also have an idea that I'm probably going to be up here at 3 for my next point, because it follows that same pattern. So here's one side. Oops. Here's the other side. And that is my absolute value function. You might need to write those numbers down. I know I did it saying the numbers out loud. Write them down if you need to. Maybe use a calculator. Whatever you got to do, just be careful with calculators. Calculators are only as smart as the person typing them. So if you type the wrong thing, calculator won't know. So I've given you a new function to try. Here are the points I suggest that you work with, because if you start too far one side or the other, you might not see the change of direction. So pause the video and resume when you're ready to check your last problem. All right. Let's check this out. 2 times negative 2 is negative 4. Plus 2 is negative 2. Absolute value is positive 2. Minus 1 is 1. I'm going to write them down first, and we'll graph a couple, because I want to see if I can see them changing here. 2 and negative 1 is negative 2. Plus 2 is 0. 0 minus 1 is negative 1. 2 times 0 is 0. Plus 2 is 2. Absolute value of 2 is still 2. Minus 1 is 1. So I did a couple, and I can actually see where it changes direction, right? It's going to go down to that, and then it's going to go back up. Negative 2, 1, negative 1, negative 1. And then it goes back up to 0, 1. Right. I have an idea of what the next ones are going to look like, but let's plug them in anyways. If I plug in 1, 2 times 1 is 2, plus 2 is 4. Absolute value of 4 is 4, minus 1 is 3. So we get 1, 3. And it's following the pattern I thought. Let's do 2. 2 times 2 is 4, plus 2 is 6. 6 minus 1 is 5. Now, I can't graph the other side, but I have an idea of what's happening. It looks like it's going up by 2s, right? 1 to 3 to 5. So this is probably a 7, and that's going to be a 9. If I was to graph it out, I'd be able to see that. And more importantly, I can see on the other side, because it's symmetrical, I'm going to have these points as well. Then we'll just fill that in. Okay, you might have gotten the graph. Did you get the points to go with it? Hey, not bad. Kind of a long one, 30 minutes, but that's it. So we'll see you at the next lesson. Peace.